At the very bottom of the world, far below where sunlight can ever reach, lies a place so deep that even Mount Everest would vanish inside it. This is the Mariana Trench, a scar in the Pacific Ocean that drops 36,000 feet beneath the surface. For centuries, people could only imagine what was hidden there. Sailors spoke of endless darkness, crushing waters, and creatures too strange to exist. But with modern submarines and new technology, explorers have finally peered into this abyss, and what they found is both shocking and unsettling. Down in that silent world, where pressure could crush a human body in seconds, life still exists, adapted, resilient, and alien in appearance. The trench is more than just a hole in the sea. It is a time capsule of Earth's history and a window into worlds that feel more like science fiction than reality. What lies there could rewrite everything we thought we knew about life on our planet. The question now is not just what lives there, but whether humanity is ready to face it. Journey to the deepest point, far below the waves of the Pacific Ocean, lies a place that seems almost impossible to imagine. The Mariana Trench, stretching nearly 11,000 meters or 36,000 feet, plunges deeper than Mount Everest is tall. It sits east of the Philippines, hidden under endless miles of open water, and it is the deepest known point on Earth. To travel into this trench is to leave behind everything familiar about life at the surface. The deeper you go, the stranger the world becomes. Sunlight vanishes quickly, leaving nothing but darkness. The temperature falls close to freezing, and the weight of the water above presses down with unimaginable force, hundreds of times greater than what we feel at sea level. At such depths, an unprotected human would be crushed instantly. Only special submarines, with thick walls and reinforced hulls, can survive the descent. Reaching the bottom is not just about exploration, it is about confronting one of the last true frontiers on our planet. Each dive into the trench is a reminder that the Earth still holds mysteries greater than any mountain, desert, or jungle we have ever explored. Entering the ocean's zones. To understand the journey into the deep sea, scientists divide the ocean into layers, each one stranger than the last. At the top is the photic zone, stretching to about 200 meters. Here, sunlight shines through the water, feeding plants, reefs, and colorful fish. This is the ocean most people know, bright, alive, and full of movement. Below it, from 200 to 1,000 meters, is the twilight zone. Light fades into shadows, the water grows colder, and the pressure rises sharply. Creatures here must adapt in unusual ways. Some have giant eyes to catch the last glow of the sun, while others reflect light to vanish into the gloom. Deeper still is the midnight zone, a realm of total darkness beginning around 1,000 meters. Here, life creates its own light through bioluminescence. Fish and squid glow like stars in a black sky. Beyond that lies the abyss, cold and endless, with soft mud plains stretching for miles. Finally, in trenches like the Mariana, we enter the Hadal zone, deeper than 6,000 meters, where only the toughest organisms can survive. Each zone is a step farther from our world above and closer to an alien world below. Life in the sunlit waters. The first stop on our journey down is the photic zone, the only layer of the ocean touched by sunlight. It stretches from the surface to about 200 meters deep, and it is here that most marine life we recognize exists. Bright beams of light pour through the water, warming it and allowing plants and algae to grow. Coral reefs flourish in this zone, creating vibrant cities of color where countless fish, turtles, and crustaceans live. Schools of shimmering fish dart in every direction, hunted by predators like sharks, dolphins, and tuna. This is the world of beauty and balance, where life thrives in its greatest numbers. It is also the zone most connected to us, since it supports much of the ocean's biodiversity and provides food for billions of people. Yet, even here, survival is a constant struggle. Each creature, from the smallest plankton to the largest whale, plays a role in a delicate web of life. Without the sunlit waters, the ocean above would be empty, and the dark layers below would never receive the fragments of food that drift down to sustain life in the deep. The Twilight Zone creatures beneath the sunlit waters lies the Twilight Zone. Here, sunlight fades into dim blue shadows before disappearing entirely. The water grows colder, and the pressure is already 10 times stronger than at the surface. This is a world of strange beauty, where life has adapted in ways that seem almost alien. Long ribbon, like oarfish drift through the gloom, sometimes reaching lengths of over 10 meters. Their silver bodies ripple like ghosts in the water. Fragile sea angels, with delicate wing-like fins, glide slowly in the dark, glowing faintly as they move. Many creatures here have enormous eyes to catch the last traces of light, while others use transparency or reflective scales to vanish into the shadows. Food is scarce, so animals must be clever hunters or patient scavengers. Some rise at night toward the surface to feed before retreating to safety by day. The Twilight Zone is not as lifeless as it seems. It is home to countless species, many still undiscovered. It is a reminder that even in fading light, life finds a way to survive. Darkness of the Midnight Zone. At about 1,000 meters down, the last traces of sunlight vanish completely. This is the Midnight Zone, a world of endless blackness stretching for thousands of meters. The water here is near freezing, and the pressure is crushing, over 100 times stronger than at the surface. Yet, even in this hostile realm, life thrives. The only light comes from the creatures themselves, glowing through bioluminescence. Lanternfish sparkle in schools like moving constellations. Anglerfish drift through the darkness, using glowing lures to draw prey close before striking with sharp teeth. The magna pinna squid floats like ribbons of silk, with arms stretching 6 meters long, waving gently in the still water. Even the blobfish, often misunderstood, survives here with a gelatinous body perfectly built to endure the immense pressure. Communication, hunting, and survival all depend on light made by the animals themselves. In the Midnight Zone, glowing signals are the language of life, proving that even in total darkness, nature finds ways to create beauty, danger, and survival. Strange life in the abyss beyond the Midnight Zone. Starting around 4,000 meters deep, lies the abyss. Here the ocean is nearly freezing and the weight of the water above presses with unimaginable force. Sunlight never reaches this far, leaving only endless plains of soft mud that stretch for miles. At first glance, the abyss appears barren and lifeless, but it hides creatures uniquely shaped by survival. Deep sea cucumbers crawl slowly across the seafloor, recycling the tiny particles of food that drift down from above. Spider crabs with long, thin legs wander the plains, while ghostly eelpouts slip through the cold waters. Food is scarce, so life here moves slowly, conserving energy in every way. Many animals grow to great sizes, giant squids and enormous amphipods. Because in this world, larger bodies endure the pressure more effectively. The abyss is not a place of abundance, but of endurance. Each creature has adapted to survive in a place where the environment seems empty and merciless. It is a realm that reminds us that even in silence and scarcity, life refuses to surrender. Into the Hadal Zone, descending beyond 6,000 meters, we enter the Hadal Zone, the deepest part of Earth's oceans. Found only in trenches like the Mariana, this zone is shaped by immense geological forces as tectonic plates collide and carve out vast chasms. The pressure here is beyond imagination, over 1,000 times stronger than at sea level, enough to crush most machines and make survival seem impossible. Yet, against all odds, life persists. Scientists have discovered tiny amphipods scuttling across the seafloor, delicate snailfish gliding through the black water, and resilient microbes thriving within the mud. These creatures have adapted to extremes that would instantly destroy surface life, proving that evolution finds solutions even in the harshest places. The Hadal Zone is not just another ocean layer. It is Earth's final frontier, a place that feels more alien than familiar. for explorers who dare to reach it. The Hadal zone is both terrifying and inspiring, a reminder that our planet still holds secrets more mysterious than the stars above. Secrets of the seafloor mud. The bottom of the ocean may look empty, but the seafloor is a vast archive of Earth's history. Its soft mud hides stories written over millions of years. Tiny fragments, known as marine snow, drift endlessly down from above. Remains of plankton, fish waste, and even the bodies of creatures too heavy to float. Over centuries, these particles settle, creating layers of sediment that can grow more than a kilometer thick. Like the rings of a tree, each layer records the passage of time, preserving evidence of climate shifts, ocean currents, and life long vanished. This mud is not just history, it plays a critical role in the planet's balance. As carbon from dead organisms sinks into the depths, it becomes locked away, slowing its return to the atmosphere. In this way, the seafloor acts as a giant carbon sink, quietly regulating Earth's climate. Hidden within the stillness of the mud are not only the remains of the past, but also the processes that help keep the future stable. The deep ocean floor is less a graveyard than a guardian of life itself. Whale falls feed the deep. In the silent depths, one of the most extraordinary events is the fall of a whale. When a giant dies and its body sinks to the seafloor, it becomes a sudden feast in an otherwise barren world. At first, large scavengers arrive, sharks tearing at the flesh, hagfish burrowing deep to feed. Soon after, worms, snails, and crabs gather to pick apart what remains. Then bacteria take over, breaking down the oils and fats within the bones, releasing chemicals that attract entire new communities of life. What was once a lifeless patch of mud transforms into a thriving ecosystem. A single whale fall can support life for decades, with specialized creatures living only on these skeletons. Tiny worms bore into the bones, while bacterial mats cover the surfaces, sustaining species rarely seen elsewhere. In death, the whale gives rise to countless smaller lives, turning tragedy into renewal. It is nature's ultimate recycling system, a reminder that in the deep sea, nothing is wasted, and even the end of one giant sparks the beginning of many. Challenger Deep first dive. The deepest point on Earth, Challenger Deep, was first reached in 1960. Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh made the daring journey aboard the bathyscaphe Trieste. Their vessel was unlike anything built before. A steel sphere suspended beneath a massive float, designed to withstand the crushing pressure over 10,000 meters below the surface. The descent took nearly 5 hours, each meter bringing more darkness, more silence, and more risk. At the bottom, they touched down on the soft, silty floor of Challenger Deep, becoming the first humans to witness this hidden world. Their stay was brief, only about 20 minutes, limited by the technology of the time, yet their achievement was historic, proving that humans could reach Earth's most extreme frontier. For decades after, Challenger Deep remained mostly untouched, but Piccard and Walsh's courage opened the door for future exploration. Their dive showed that even the most unreachable places on our planet could be explored if humans dared to try. James Cameron's solo mission. More than 50 years after the first dive, Challenger Deep was visited again, this time by filmmaker and explorer James Cameron in 2012. Unlike earlier missions, Cameron went alone, piloting a sleek green submersible called the Deep Sea Challenger. His vessel was custom, built for the extreme conditions, designed to endure the crushing pressure 7 miles below the surface. The descent lasted nearly 2.5 hours, during which Cameron sat confined in a narrow capsule, surrounded by darkness and silence. When he finally reached the bottom, he became only the third human in history to stand at Earth's deepest point, and the first to do it solo. Unlike Piccard and Walsh, Cameron's mission was equipped with advanced cameras and tools, allowing him to capture high-definition video and collect samples from the seafloor. His dive revealed an alien world of mud rock and resilient life, offering scientists material to study for years to come. It was not just a technical triumph, but also a moment of human persistence, proving curiosity can push us into the most hostile corners of the planet. Vescovo's deep research. In the late 2010s, American explorer Victor Vescovo set out to make Challenger Deep not just a place for rare visits, but for ongoing science. Piloting his submersible limiting factor, he achieved multiple dives into the trench, something no one had done before. Unlike earlier craft that could only survive a single journey, the limiting factor was designed to go down again and again, opening the door to systematic research rather than one-time milestones. Vescovo's missions mapped the seafloor in detail, collected samples, and recorded conditions that had never been studied so closely. His repeated descents proved that Challenger Deep was not unreachable, but a frontier that could be explored with discipline and technology. Each dive demanded precise engineering, as the pressure more than 1,000 times stronger than the surface meant even a tiny flaw could be fatal. Through his work, Vescovo turned the deepest pit on Earth from a mystery into a research site, showing that persistence, innovation, and courage could turn the impossible into routine discovery. China's Fendouzé triumph. A new chapter opened in 2020 when China's submersible Fendouzé made its record-breaking dive into Challenger Deep. Unlike earlier missions with a single passenger, Fendouzé carried a crew of 3 aquanauts, marking a bold step forward for China's deep sea ambitions. The mission was more than symbolic. It showed that the nation had developed the technology to withstand the most hostile environment on Earth. At the bottom, the crew recorded observations, collected samples, and conducted experiments, proving that science could be done in real time at 36,000 feet below the surface. For China, this was not only a scientific milestone, but also a statement of global presence. By reaching these depths with a crewed mission, they joined the small group of nations capable of extreme exploration. The Fendouzé dive revealed that the race to explore and control the ocean's secrets was no longer limited to a few pioneers. It had become part of a larger competition, one that could shape the future of science, resources, and power beneath the sea. Rise of deep sea robots. For centuries, the deepest parts of the ocean were thought unreachable, places too dangerous for humans and too harsh for machines. That began to change in the 2020s when explorers turned to robotics. Instead of relying only on massive submersibles carrying people, engineers developed fleets of small, autonomous robots designed to work on their own. These machines, some no larger than a shoebox, could dive into crushing depths without cables or surface control. Powered by advanced batteries, they roamed for hours or even days, crawling along the seabed, gliding through the water, or collecting samples in silence. Unlike crewed dives, which cost millions and carried great risk, dozens of these robots could be deployed at once, mapping huge areas and gathering data faster than ever before. If one was lost, the mission continued. This marked a revolution in exploration. The ocean floor could finally be studied not once a decade, but continuously. The rise of deep sea robots turned the most remote frontier on Earth into a laboratory where discovery was no longer rare, but routine. Fleets of tiny explorers. The real breakthrough in deep sea research came when robots were no longer used one at a time, but in fleets. Instead of sending a single expensive vessel into the trench, scientists could launch dozens, or even hundreds, of small, specialized machines together. Some glided silently through the water, scanning wide stretches of the seafloor and sending back maps and images. Others crawled across the mud plains on mechanical legs, studying life up close and collecting samples of rocks, microbes, and sediment. Each robot was built for a task, and when their data was combined, it created a picture of the deep far richer than ever before. These fleets were also affordable, making deep exploration possible for more nations, universities, and research groups. For the first time, The deep ocean was no longer the exclusive domain of a handful of powerful countries. It became a shared frontier. By spreading across the abyss together, these tiny explorers revealed that the secrets of the ocean could finally be unlocked piece by piece, not by rare missions, but through constant discovery. Treasures of cold seeps hidden on the seafloor are strange places called cold seeps, where methane and hydrogen sulfide leak slowly from cracks in the earth. To most life, these chemicals would be deadly, but in the deep sea they create entire ecosystems. Microbes feed on the gases through a process called chemosynthesis, turning poison into energy. Around them, giant clams, mussels, and tube worms, some longer than a human, flourish in dense colonies. These creatures depend not on sunlight, but on their partnership with the microbes inside their bodies. Cold seeps are oases in the deep, thriving in total darkness under immense pressure. They prove that life can adapt to conditions that seem impossible, surviving without light or warmth. For scientists, they offer more than wonder. They may reveal how life began on Earth, and even how it might exist on other worlds with extreme environments. Cold seeps remind us that the deep sea is not just a place of mystery, but a source of answers to some of the oldest questions about life itself. Fire ice of the seafloor. Among the strangest discoveries in the deep is methane hydrate, often called fire ice. At first glance, it looks like ordinary frozen water, but inside its icy cages are molecules of methane gas. When lit, this substance burns with a bright flame, ice that can catch fire. Fire ice forms only under special conditions, low temperatures and crushing pressures, like those found thousands of meters beneath the sea. Scientists believe the deposits of methane hydrate on the ocean floor hold more potential energy than all the known coal, oil, and natural gas reserves on Earth combined. This makes it one of the most promising future energy sources. But hidden within that promise is danger. If disturbed, methane hydrates could destabilize the seafloor, causing underwater landslides or even tsunamis. Worse still, if large amounts of methane escape into the atmosphere, it could accelerate climate change dramatically, since methane traps far more heat than carbon dioxide. Fire ice is both treasure and threat, a frozen fuel that could power civilizations or unleash disaster if handled recklessly. Metals hidden in nodules scattered across the deep seafloor are strange, potato-sized rocks called polymetallic nodules. At first they look ordinary, but inside they are packed with valuable metals: cobalt, nickel, copper, and manganese. These elements are essential for building batteries, powering electric cars, smartphones, and renewable energy systems. What makes nodules remarkable is how they form. Over millions of years, layer by layer, minerals slowly build around a tiny core, often the shell of a creature or a grain of sand. The process is so slow that a single nodule can take millions of years to reach the size of a fist. Yet today, demand for these metals is rising faster than ever as the world shifts toward green energy. To many, the ocean floor seems like the perfect solution, a vast reserve of the resources we need. But the nodules are not just minerals, they are habitats. Tiny creatures live on and around them, forming fragile ecosystems. Mining these nodules might fuel our future, but it could also destroy life forms we are only beginning to discover. Dangers of deep sea mining. The treasures of the deep come with a heavy price. Mining polymetallic nodules or drilling into methane hydrates is not a clean process. Massive machines scrape across the seabed, crushing habitats that took millions of years to form. The disturbance creates vast clouds of sediment that drift for miles, smothering fragile creatures and disrupting food chains built over centuries. Unlike shallow waters, where ecosystems may recover in decades, the deep sea heals at an incredibly slow pace, if it heals at all. Scientists warn that mining here could leave scars lasting thousands of years, permanently altering a world we barely understand. Beyond the immediate damage, Waste plumes from mining could spread even farther, spreading chaos across delicate environments that support unique forms of life. For all the metals and fuels we seek, the cost may be the destruction of ecosystems that have survived in silence since the dawn of time. The choice before humanity is stark: treat the ocean as a vault to be emptied, or as a living frontier to be protected. Fragile internet cables beneath the world's oceans lies a hidden network that keeps modern life running undersea internet cables. Those satellites often capture attention. More than 95% of global data flows through these fragile lifelines. No thicker than a garden hose, they stretch for thousands of miles across the seabed, carrying banking transactions, stock trades, government messages, entertainment streams, and personal calls. Wrapped in layers of steel and insulation, they can endure natural pressure, but they are far from indestructible. An anchor dragged across the seafloor, an earthquake shifting the ground, or even a curious shark bite can snap a line and plunge nations into digital blackouts. Repairing them is slow and difficult. Special ships haul the cables up, splice them carefully, and lower them back down. But beyond accidents, a darker threat looms. Rival powers could sabotage cables, cutting them quietly and crippling economies. What seems invisible and secure is in truth vulnerable, reminding us that the foundations of our connected world rest on fragile strands hidden in the deep. Race for control of the deep. The deep sea is no longer just a place of mystery. It has become a new frontier of power. While Western nations cut funding, China is moving quickly, building advanced submersibles, training scientists, and planning the first permanent base 2,000 meters underwater. This base, like a space station beneath the waves, would allow researchers to live for weeks on the seafloor, running experiments, testing technology, and studying ecosystems in real time. Such a project shows ambition beyond science. It is about influence, control, and resources. Whoever leads in deep sea exploration will have the advantage in securing metals, monitoring vital internet cables, and shaping international rules. But this race carries risks. The fragile ecosystems of the trenches have taken millions of years to form and may never recover if disturbed. Mining, construction, and constant human presence could cause damage that lasts for ages. The question is no longer whether we can control the deep, but whether we should. Will this new frontier bring progress, or will it bring destruction that cannot be undone?